Good morning to everyone. So we shall continue with today's class. So in yesterday's class, we all studied definition of homomorphism and the definition of isomorphism. So once again, we will revise it and move on to the next properties of homomorphism. Okay. Totally, there are four properties. Okay, totally there are four properties. I will be explaining only two to you, and two is your assignment. Another two is your assignment. Okay, another two is your assignments. Okay, so listen carefully and write it down. Afterwards, you must send an assignment by in a Google form. Okay, so in yesterday's class, we studied about homomorphism and isomorphism. Okay, yesterday's class homomorphism and isomorphism and isomorphism. Okay, so the statement of a homomorphism is f of a dot b is equal to f of a into f of b for all a comma b belongs to G. Okay, this is your expression. It must satisfy this condition. Then only we call it as an homomorphism. Okay, then only we shall call it as an homomorphism. Okay. So and the mapping so ಇಲ್ಲಿ mapping ಆಯ್ತಂದ್ರೆ so x ಇತ್ತಂದ್ರೆ x dash f of x ಆಗುತ್ತೆ, x1 ಇತ್ತಂದ್ರೆ f of x1 ಆಗುತ್ತೆ ಇಲ್ಲಿನ values, so on so ಹೆಂಗಿರ್ತಾವ. So next isomorphism means ಏನಾಯ್ತಂದ್ರೆ a mapping from f from G to G bar. G to G bar is said to be isomorphism. G ನಿಂತ G bar ಗೆ ಮ್ಯಾಪಿಂಗ್ ಆದಾಗ ಏನಂತೀವಿ ನಾವು, ಅದಕ್ಕೆ isomorphism ಅಂತೀವಿ. So but it must satisfy this condition. Three condition ಅಲ್ಲಿ. So f ಅನ್ನ homomorphism ಆಗಿರಬೇಕು. F is homomorphism ಆಗಿರಬೇಕು. And condition 2 is f 1 to 1 functioning ಆಗಿರಬೇಕು. F is 1 to 1 functioning ಆಗಿರಬೇಕು. And third condition is F2 must be onto condition. F is onto ಇರಬೇಕು. So ಈ ಮೂರು condition satisfy ಆಯ್ತದ, we can say that isomorphism is satisfied. It can be happen isomorphism. So these are the definitions of homomorphism and isomorphism. In today's class, we shall study about the properties of homomorphism and isomorphism of properties. So next, properties of homomorphism. Properties of homomorphism. Properties of homomorphism. So it's theorem number 37. Okay. So statement says that. Statement in the order. If f is a homomorphism, of G into G bar, then first condition f of E is equal to E bar, where E E and E bar are identities of are identities identities of G and G bar. Okay. And the next condition, what does it say? Means next condition I know f of x is x inverse f of x inverse is equal to f of x whole inverse for all x belongs to G. Okay, this is your first property of the theorem's property. Okay, so what are the theorem statement says? If f is a homomorphism and f is a homomorphism of G into G bar. So f into mapping the G into G bar mapping then f of E is equal to, this is equal to not really, sorry, z and this is equal to E bar. There is not first condition if f is E is equal to E bar itandara, where E and E bar are identicals of G and G bar, means G do E is equal to G agbodu and E bar belongs to G bar agbodu, means condition you satisfy. So next is f of x inverse is equal to f of x whole inverse for all x belongs to G and Z. Okay, na? These are the given conditions for you. Next we shall see the proof for this. Okay, next we shall see the proof for this. Okay, we shall see the proof for this. Okay, so next, for all x belongs to G, comma, therefore we can write x is equal to x e. E andre identicals. So ನಮ್ಮ identicals ಇಂದು ಇದು ಬೇಕಾಗಿತ್ತು. Where next ಬರೀತೀನಿ ನೋಡಿ, where E ಅನ್ನೋದು E is an identity of G. Okay, where E is an identity of G. Where E is the identity of G. Okay, E is the identity of G, so we can write x is equal to xe. So then for all f of x is equal to, we can say that f of mapping ಮಾಡಿರ್ತೀವಿ f of xe ಆಗುತ್ತೆ. So mapping ಮಾಡೋಣ, f of x is equal to f of xe ಆಗುತ್ತೆ. So by the theorem, by the definition of homomorphism, ನೋಡ್ರಿ ಹೆಂಗ್ ಬರೀತೀವಿ, by using the definition of homomorphism. Shortcut homomorphism. By using the definition of homomorphism, we can say that f of x is equal to f of x into f of e. This is how we written by the definition of a homomorphism. Okay, don't be confused. The hand to by the definition of homomorphism. So we can write this. E mapping ಮಾಡಿದೆವು. So afterwards mapping split ಮಾಡಿದಾಗ f of x is equal to f of x is equal to f of x into f of e ಆಯ್ತು. Okay, next page I will read. Next considering let e bar is the identicals of G bar, right? Identity of G bar, and we know that f of x belongs to G bar. Okay, f of x belongs to G bar. So I left out here the equation 1. So this is your equation 1. Okay, so next equation 1 miss ಮಾಡಿದ್ದೆ, so let's continue further. So next So what does this say? Let E bar is an identity of G bar. Now already statement here again. So E and E bar are the identicals of G and G bar definitionally. So I said that already that E is the identity of G and E bar is an identity of G bar. Okay. Now they are saying E is the identity of G bar. E bar is the identity of G bar. That you know that f of x is also belongs to G bar. Already the question will go f of x belongs to x belongs to G, and then directly we can say that f of x also belongs to G. So next, therefore f of x into E bar is equal to f of x. Okay. One second. So, value ಏನು ಬಂದಿತ್ತು ಇಲ್ಲಿ f of x into f of e value. So in the statement ನೋಡ್ರಿ in condition 1 ನ ನೋಡ್ರಿ ಏನು ಕೊಟ್ಟಾರ f of x f of e is equal to ಏನದ directly e bar ಬರ್ದಾರ ಹೌದಾ directly e bar ಬರ್ದಾರ. So in next ಇಲ್ಲಿ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಂದ್ರೆ f of x into ಇಲ್ಲಿ ಏನೈತ್ರಿ ನಮಗ ಅಗಲಿನ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನಾಯ್ತು f of x into f of e is equal to f of x ಇತ್ತು. So ನಾವು ಇಲ್ಲಿ ಏನು ಬರಲಿತ್ತೀವಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ನಾಗ ಏನು ಬರಲಿತ್ತೀವಿ ನೋಡ್ರಿ sorry ಈ ಇದೇನ ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಇದು ಹೆಂಗ್ ಬರೀತೀವಿ ನೋಡಿ ನಾವು ಇಲ್ಲಿ. So f of x ಅಂತ ಬರ್ಕೊಂಡೆ as it is ಇಲ್ಲಿಂದು. So next ಏನು ಮಾಡ್ತೀನಿ f of into as it is f of e ಇದು e bar ಮಾಡ್ಕೊತೀನಿ is equal to f of x as it is ಇರ್ತೀನಿ ಸೇಮ್ ಸ್ಟೆಪ್ ಅಂತ ನೋಡ್ರಿ. ಅದು ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ ಈ ಸ್ಟೆಪ್ಸ್ ಎಲ್ಲಿಂದ ಹೋಗ್ತಾರೆ. So this is how we write the steps. So ಆ ತರ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಈ ಸ್ಟೆಪ್ ಬರ್ದಿದ್ದೀನಿ ನಾನು. So f of x into e bar is equal to f of x. Therefore we can write this. So ನಾವು ಈ ತರ ಬರೀಬಹುದಲ್ಲ ಈ ತರ ಬರೀಬಹುದು f of x is equal to f of x into e bar. This is your statement equation number 2. Okay, this is equation number 2. So ಇದರಲ್ಲಿ difficulty ಇಲ್ಲ ಅನ್ಕೊಂಡಿದ್ದೀನ. So and ಅಲ್ಲಿಂದ terms ತಗೊಂಡು ಅಷ್ಟೇ condition given statement ನ given statement ಅಲ್ಲಿ condition ಕೊಟ್ಟಿರು ಅದು ಡೈರೆಕ್ಟ್ ಇಂದ ಇನ್ಪುಟ್ ಮಾಡೋಣ. So next we can write by interchanging this. So I have written like this. Now from equation 1 and 2, from equation 1 and 2 we have that f of x into f of e is equal to f of x into e bar. Okay, by using these two definitions. So first statement naga first equation naga ಏನಿದ್ರೆ ಇದೆ ಇತ್ತು ಏನಪ್ಪಾ ಅಂದ್ರೆ ಇದೆ f of x into f of x is equal to f of x into f of e ಇತ್ತು. So next equation naga f of x is equal to f of x into e bar ಅದ. So ಎರಡು equations ಅನ್ನು ತಗೊಂಡು I have written by equation 1 and 2 we have written that f of x into f of e is equal to f of x into e. Now by the left cancellation method. So left cancellation method ಏನಾಗ್ತದೆ left cancellation method cancel ಆಗ್ತದ. So f of e is equal to e bar ಹೋಗ್ತದೆ value. So by left cancellation method agar nam values ಏನು ಹೋಗ್ತವ್ರೆ f of e is equal to e bar ಆಗುತ್ತೆ value. Okay, so ಇಲ್ಲಿ ತನಕ ನಿಮ್ಮದು ಫಸ್ಟ್ ಪ್ರೂಫ್ ಬಂತು. ಇಲ್ಲಿ ತನಕ ಏನು ಹೋಗಿದ್ರಿ ಫಸ್ಟ್ ಪ್ರೂಫ್ ಮುಗಿಯಿತು. ಓನ್ಲಿ ಕಂಡೀಷನ್ ಎರಡು ಕಂಡೀಷನ್ ಕೊಟ್ಟರು ನಮಗೆ ಇಲ್ಲಿ ಹೌದಾ ದ ಗಿವನ್ ಕಂಡೀಷನ್ ಈ ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿವಿ. ಸೊ ಈ ಅದು ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಫಸ್ಟ್ ಪ್ರೂಫ್ ಮಾಡಿವಿ. ಸೊ ಓನ್ಲಿ ಫಸ್ಟ್ ಪ್ರೂಫ್ ಆಯ್ತು. ಸೆಕೆಂಡ್ ಪ್ರೂಫ್ ಒಂದು ಓದೋದು ಹೌದಾ. ಸೊ ಫಸ್ಟ್ ಪ್ರೂಫ್ ನ ಏನೇನ್ ಮಾಡಿದ್ರು ನೋಡ್ರಿ. ಸೊ ಫಸ್ಟ್ ಪ್ರೂಫ್ ಅಲ್ಲಿ ಇದು ಬೈ ಯೂಸಿಂಗ್ ಫಸ್ಟ್ ಪ್ರೂಫ್ ಫಾರ್ ಆಲ್ x belongs to g so that already in the given statement ಕೊಟ್ರೆ x belongs to g ಅಂತ ಹೇಳಿ. So by using that x equal to xe where e is an identity of g. So g is the identity of e multiply agade. So therefore we will write f of x is equal to f of x into e. Now by using the definition of homomorphism we can write that f of x is equal to f of x into f of e. Okay, this is equation 1. So in equation 2 what now equation 2, let E bar is the identity of G bar. We know that f of x belongs to G bar. Okay, so x belongs to G and obviously f of x belongs to G bar ಅಲ್ಲ. So already na mapping na ಹೇಳಿದೆ ನಿಮಗೆ x ಇತ್ತು x ನ g ಇಲ್ಲಿ g ನ x ಇತ್ತು next f of ಎದಾಗ g bar ನ ಏನಾಗಿರ್ತದೆ f of x ಹಾಗೆ ಆಗಿರ್ತದೆ x1 ಇತ್ತಂದ್ರೆ f of x1 ಆಗಿರ್ತದೆ. ಮತ್ತೆ ಇದು ಗೊತ್ತಿಲ್ಲ you must be knowing the basics of your basics ಗೊತ್ತಿರಬೇಕು ಡೊಮೇನ್ ಕೋಡೊಮೇನ್ ಎಲ್ಲಾನು ಗೊತ್ತಿರಬೇಕಲ್ಲ. So we f of x belongs to G bar. Okay, so next f of x is into f of ಇಲ್ಲಿ ಏನು ಹೇಳ್ತೀರಾ ಮಗ by using the f of x into E bar is equal to f of x by E bar ಎದು ಬರ್ಕೊಂಡಿರೋದು f of E bar f of E ಇದಕ್ಕೆ f of E bar ಬರ್ಕೊಂಡಿವಿ. So next by interchanging this we written f of x is equal to f of x into E bar. So this is equation 2. By from equation 1 and 2 we have that f of x into f of E is equal to f of x into E bar. So now by left cancellation method left cancellation method by left cancellation method we have that by left cancellation method we have that now by left cancellation method we cancel the f of x terms. So by after that we remains f of E is equal to E bar. This is your the first conditions proof. Okay, afterwards next second condition. So I will go with the second condition now. Condition number 2. So that is so condition number 2 ನ ಏನು ನೋಡ್ರಿ f of x bar is equal to f of x whole bar. Okay, so for all x belongs to G. Okay, so this is your second proof. So next we shall go with it. So x bar is equal to proof and proof nodri. So for all x belongs to G ಅಂತ ಹೇಳಿದ್ದಾರೆ ಅವರು. So x ಅನ್ನ ಗ್ರೂಪ್ ಇದ್ದಾಗ ಒಂದರ ಎಲ್ಲ ಟರ್ಮ್ಸ್ ನು ಒಂದು ಇನ್ವರ್ಸ್ ಇದ್ದೇ ಇರ್ತದೆ. So you can write x inverse belongs also to G. x and x belongs to G ಅಂದಾಗ x inverse also belongs to G ಆಗಿ ಇರ್ತದೆ. x belongs to G ಇದ್ರೆ obviously x inverse belongs to G ಇದ್ದೇ ಇರ್ತದೆ. Okay, so we can write that x into x bar belongs to G. Okay, x into x bar belongs to G by closure axioms. You can say by the closure axioms or by the associative property. Okay, ಎರಡರ ಒಂದು ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. ಇಲ್ಲಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ only closure properties closure axioms ಕೊಟ್ಟಾರ. So or you can use by the property closure property associative property. So this is why now after mapping so f of x into x inverse is equal to f of x into f of x inverse ಅದು ನೋಡಿ f of x inverse ಆಗಿರ್ತದೆ. Okay, therefore by the definition of homomorphism by the definition of homomorphism is by the definition of homomorphism equation is equation number 3 ಅದರ ಇದು. So equation number 3 also implies that x inverse is equal to E. So okay, x inverse is equal to E. Therefore we can say that f of x inverse is equal to f of E is equal to E bar. Okay, we can say that f of x inverse already groups ಅಲ್ಲಿ ಓದಿದ್ದೀವಿ. x inverse ಏನಾಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ ನಮ್ದು E ಆಗುತ್ತೆ. So we can write that f of x into x inverse is equal to f of E. ನಮ್ದು f of E value ಅಂದ್ರೆ E bar ಅಂತ. Okay right? So these systems we know this. ಯಾಕಂದ್ರೆ ನಿಮಗೆ ಇದರ ವ್ಯಾಲ್ಯೂ ಬಂತು, ಇದು ಈಕ್ವೇಷನ್ ನಂಬರ್ 3 ಆಯ್ತು. ಸೊ ನೆಕ್ಸ್ಟ್ ಇದು ಎಲ್ಲಿ ಅಂತ ನೋಡಿದ್ರೆ ಬೈ ಕಂಡೀಷನ್ ಬೈ ದ ಗ್ರೂಪ್ ನಾಗ ನಾವು ಇದು ಓದಿವಿ x ಇನ್ವರ್ಸ್ ಇದ್ರ ವ್ಯಾಲ್ಯೂ ಏನಂತೀರಿ E ಆಗುತ್ತೆ. ಸೊ ಬೈ ದಟ್ f of x x inverse ಇದೆ ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀನಾ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇವು ಎರಡು ಟರ್ಮ್ ಏನಾದ್ರಿ f of e ಆಗುತ್ತೆ. ಸೊ f of e ಆದಾಗ ಸೊ f of e ವ್ಯಾಲ್ಯೂ ಏನಂಗ e ಇನ್ವರ್ಸ್ ಅದ. ಇವು ಎರಡು ವ್ಯಾಲ್ಯೂ e ಆಯ್ತು ಅಂದ್ರೆ x x ಇನ್ವರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ನಮಗೆ e ಅದ. ಸೊ ಅದಕ್ಕೆ ನೋಡೋಣ f of e ಬರ್ಕೊಂಡ್ಬಿಟ್ಟಿವಿ. ನಮ್ಮ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ f of x x ಇನ್ವರ್ಸ್ ಅದ. ಸೊ ಈ ಜಾಗಕ್ಕೆ ನಾವು e ಅನ್ನು ಬರ್ಕೊಂಡ್ಬಿಟ್ಟಿವಿ. ಸೊ f of e ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ e ಬಾರ್ ಅದ. ಸೊ we have written this f of x x inverse is equal to f of e is equal to e bar. Okay, now from next page I will be explaining this from 3. So next from this is the equation number I don't know where this is your equation number 4. Okay, so next from 3 and 4 from 3 and 4 from 3 and 4 we know that f of x into f of x x inverse is equal to e bar. Okay, okay, the inverse of next that implies the inverse law ಏನಂತ ನೋಡ್ರಿ, the inverse of f of x is the inverse of f of x is ಏನಂತ್ರಿ f of x inverse. So for that we will be writing f of x whole inverse is equal to f of x inverse. Okay, for all g belongs to capital G. X belongs to capital G. Okay, so next by the form 3 and 4 equation number 3 third and fourth consider ಮಾಡ್ತೀವಿ. third and fourth consider ಮಾಡೋಣ. So next ನಮ್ಮ ವ್ಯಾಲ್ಯೂಸ್ ಏನು ಮಾಡೋದು f of x into f of x x inverse is equal to e bar ಬರುತ್ತೆ ನಮ್ಮ ವ್ಯಾಲ್ಯೂಸ್. Okay, so now the inverse of f of x is equal to f of x, the inverse of f of x in value ಏನಂತಾರೆ f of x in value ಏನಂತ f of x inverse ಆಗ್ತದೆ. So f of x in inverse ಏನಾಗುತ್ತೆ ನಮಗೆ f of x the inverse of f of x ಏನಂತ ನಮಗೆ f of x inverse ಆಗುತ್ತೆ. So by that we write this f of x whole inverse is equal to f of x for all x belongs to G. Okay, so next second condition ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. So condition ಏನು f of x inverse is equal to f of x whole inverse ಆಗಿರುತ್ತೆ ನಾವು values. Okay, so for all x belongs to G daga x in obviously we can say that x inverse belongs to G. So for that we write x inverse belongs to G. ಎರಡು condition ಇದನ್ನ x belongs to G adare, so x inverse belongs to G ada. By both these we can write this na, by this we can write this. Okay, x inverse belongs to G aಗುತ್ತೆ. So next by applying the definition of homomorphism we can say that f of x into x inverse is equal to f of x into f of x inverse. So by the values of projection we can say that x inverse ಏನಂದ್ರೆ e at the value. So next f of x inverse is equal to f of e ಬರ್ಕೊಂಡಿ f of e ಅಂದ್ರೆ value ಅಂದ್ರೆ ನಮಗೆ e inverse ಅದ. It is equation number 4. This is equation number 3. Now by using 3 and 4 by using equation 3 and 4 f of x into x inverse is equal to e bar ಆಗುತ್ತೆ ನಮಗೆ. Okay na? So the inverse of f of x ಏನಿರುತ್ತೆ f of x inverse ಏನಿರುತ್ತೆ f of x inverse ಆಗಿರುತ್ತೆ. By this we can write this f of x whole inverse is equal to f of x for all x belongs to G. Okay, this is your first properties of an homomorphism. So next property ಹೋಗೋಣ. Next property we shall say that there number 38 other property homomorphism properties that there number 38 number. Okay, so there number 38 if f of G tends to G bar is a homomorphism is a homomorphism. Homomorphism. Then the range the range the range of f that is f of g is equal to f of a bar, sorry, f of a slash for all a belongs to g is a subgroup and that what is the subgroup is subgroup of G bar. So next answer, if f of f tends to f of g tends to g bar, f of g tends to g bar also mapping is a homomorphism ಅಂತ ಹೇಳ್ತಾರೆ ಅವರು. Then the range ಅಂದ್ರೆ range defines means element term means 1 2 3 4 5 6 7 7 ನ ಇದು 3 to 7 ನಾವು range ಅಂತ ಕರೀತೀವಿ ನಾವು. This is called range. But the range ಅಂದ್ರೆ ಏನು ಪ್ಲಸ್ ಮಾಡ್ಕೋಬೇಕು. So this is our range. Okay, the range of f, that is in range the ಅಂದ್ರೆ f of g is equal to f of a slash for all a belongs to g is subgroup of g bar ಅಂತ ಹೇಳ್ತಾನೆ. Okay, so next property ಏನಾದ್ರು ನೋಡೋಣ. since f of a is equal to f of a belongs to g bar for all a belongs to g. So f of a that belongs to g bar for all a belongs to g is the g bar. So we can obviously write that f of g is a subset of g bar. Okay, nodri in the values is f of a belongs to g bar. Okay, we know that f of a belongs to g bar ikandre alli a belongs to g bar andre f of a belongs to g bar ಆಗಿರುತ್ತದೆ value mapping that for all a belongs to g ಆಗಿರುತ್ತದೆ. So we can write that f of g is a subset of g bar. Adrದು subset ಇರುತ್ತದೆ. Okay, now let us continue. Let x bar comma y bar belongs to f of g be arbitrary. Consider ಮಾಡ್ಕೊಳ್ಳುತ್ತೀರಿ, confusion ಆಗಬೇಡ್ರಿ. ಇದು arbitrary to show that next video to show that f of g is a subgroup we establish so therefore x bar into y bar of inverse is equal to belongs to f of g. Okay, so now to show that f of g is a subgroup we established. So now f of g no subgroup ಅಂತ ಪ್ರೂವ್ ಮಾಡೋದು ನಮಗೆ. ಸೊ ಅದಕ್ಕೆ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ ಅಂದ್ರೆ x bar into y bar whole to the power x bar y to the y bar inverse belongs to g f of g ಅಂತ ತಗೊಳ್ತೀವಿ. It clearly defines that f of g clearly by the definition of f of g, by the definition of f of g, we say that that implies x bar is equal to f of x and y bar is equal to f of y. Okay, for some x belongs to and y belongs to g, y belongs or xy belongs to g. Now considering now considering that x bar into y bar whole inverse is equal to f of x into f of y whole bar. So next, this is how we write into f of x into f of y inverse, f of y inverse. This is by the theorem number 37 ने बहुत theorem ना define ಮಾಡಿದ already previous theorem define ಮಾಡಿ already. Now ಇದನ್ನ f of x y inverse ಬರೀತೀವಿ by definition of homomorphism. So ಒಂದಕ್ಕೊಂದು theorem connective ನೋಡ್ರಿ ಇವು by the definition of homomorphism. So next page I will be explaining of this. So that is x bar into y bar inverse is the image of x into y inverse under f. Okay. Since x into y inverse belongs to G, that implies f of x y inverse belongs to f of G. X bar into y bar whole to the power of inverse belong to f of G for all x bar y bar belongs to f of G. Therefore, hence we can write that hence f of G is a subgroup of G bar. Okay, f of x is a subgroup of G bar. Okay, this is your third property number 2. Okay, this is your property number 2. So I will start with it from first. So that is if f of G tends to G bar is a homomorphism, then then the range of f, that is f of G is equal to f of a bar for all a belongs to G is a subgroup of G bar. So first thing consider ಮಾಡಿ f of a belongs to G ಅಂತಂದ್ರೆ f of a that belongs to G bar. So already ನಮ್ಮ ಮ್ಯಾಪಿಂಗ್ ಗೆ ಏನೇನ್ರಿ a belongs to G ಅಂತಂದ್ರೆ a bar ಏನಿದ್ರಿ a or a dash a bar or a bar ತೋರಿ a double dash ತೋರಿ ಅದು G bar ಗೆ ಡಿಫೈನ್ ಆಗಿರುತ್ತೆ. ನಾವು ಇಲ್ಲಿ G bar ಅಂತ ಮಾಡಿ ಅದಕ್ಕೆ a bar ಅಂತ ಬರಲ್ಲ ನಾವು. That is f of a belongs to G bar. Okay, for all a belongs to G ಇದ್ದಾಗ ಅಷ್ಟೇ. Okay, next a belongs to B ಇದ್ದಾಗಲಿ f of B belongs to G bar ಆಗುತ್ತೆ ನೋಡಿ. Okay, so now by this we can write that f of G is a subset of G bar. ಇದನ್ನ ಇದು subset ಆಗಿರುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಇದು. Okay, so therefore let now considering x bar and y bar belongs to f of G. So x bar ಮತ್ತು y bar that belongs to f of G. So x values ಇದೆ ಅಂದ್ರೆ x bar values f of G ನಾಗ ಇರ್ತಾವ. So x values G ನಾಗಿದ್ರೆ x bar values ಎದ್ರ ಇರ್ತಾವ್ರಿ f of G ನಾಗ ಇರ್ತಾವಲ್ಲ. So ಮ್ಯಾಪಿಂಗ್ ಇಲ್ಲಿಂದ ಮ್ಯಾಪಿಂಗ್ ಅದ G ಇದ್ರೆ f of x ಇದ್ರೆ f of x ಆಗಿರ್ತದೆ ವ್ಯಾಲ್ಯೂಸ್. Okay, G bar ನು ಇದ್ರಾಗ ಇರ್ತಾವ ವ್ಯಾಲ್ಯೂಸ್ G. Okay, next x and x bar belongs to f of G is an arbitrary. So ನೋಡ್ರಿ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡಬೇಡ್ರಿ. ಇಲ್ಲಿ ನಾ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಲ್ಲಿ ಡ್ಯಾಶ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಇಲ್ಲಿ ನಾವು ಯೂಸ್ ಮಾಡೋದು G and G bar. ಇಲ್ಲಿ G ಇತ್ತಂದ್ರೆ G ಇತ್ತಂದ್ರೆ G bar ಇರುತ್ತೆ, A ಇತ್ತಂದ್ರೆ A bar ಇರುತ್ತೆ, ಇಲ್ಲಿ X ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿ X bar ಇರ್ತದೆ, ಇಲ್ಲಿ ಸಾರಿ X bar, Y ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿ Y bar ಇರುತ್ತೆ. ಕನ್ಫ್ಯೂಷನ್ ಆಗಬೇಡ್ರಿ, ಹೇಳ್ತೀನಿ. X ಸೊ ಗ್ರೂಪ್ಸ್ ತಿಳಿಯೋದು ಕಷ್ಟ, ಸೊ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಕರೆಕ್ಟ್ ಮಾಡಿ ನೀವು ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ತಿಳಿಯುತ್ತದೆ. ಗ್ರೂಪ್ ಅಷ್ಟು ಈಸಿ ಯಾವುದು ಆಗಲ್ಲ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಇಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್. ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ, ನೆಕ್ಸ್ಟ್ ಪೇಜ್. ಓಕೆ, to show that f of g is a subgroup. So ನಮಗೆ ಏನು ಪ್ರೂವ್ ಮಾಡದ ವ್ಯಾಲ್ಯೂ f of g is a subgroup ಅಂತ ಪ್ರೂವ್ ಮಾಡದ. So x bar into f bar whole inverse belongs to f of g ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಇಲ್ಲಿ. So clearly by the definition of f of g, f of g you can say that x bar is equal to f of x, y bar is equal to f of y bar for some x comma y belongs to g, for some x comma y belongs to g. Okay, now considering f into y x bar into y inverse is equal to f of x into y of x f of y whole bar. Okay, so next multiplying this bar inside, so f of x into f of y bar, f of y inverse, f of y inverse became by the definition. This is by the definition of homomorphism. ಇದನ್ನ theorem number 37 explain ಮಾಡಿ ನೋಡ್ರಿ ಹೆಂಗ್ ತಗೊಂಡಿವಿ ಅಂತ ಹೇಳಿ. So ಇದನ್ನ by the next step is this is by the definition of homomorphism. So next that is x bar into y bar whole inverse is the image of x into y inverse under the f. So na already ಹೇಳಿದೆ, ಇದು image codomain the image is pre-image, and sorry, this is image and this is pre-image. Okay, image and pre-image ಅಂತ ಹೇಳಿದ್ರು already is values. So since x into y inverse belongs to g, for that implies f of x y inverse belongs to f of g. Therefore we shall write that f x inverse into x bar into y bar whole inverse belongs to f of g. For all x bar and y bar belongs to f of g. By this, f of g is a subgroup of g and have another condition. Okay, this is your property number 2, and we shall see another two more properties is your assignment. So I will go directly next topic is kernels of homomorphism. Okay, kernels of homomorphism I will be explaining in the next class. This is your last topic, that is kernels of homomorphism. Okay, I will be explaining in the next class of upcoming classes. Okay, thank you.